Hello, my name is Carla, and today I'm going to give a timeline with the main developments of the computer component, the microprocessor, over the last 2 decades. Intel Corporation was founded on July 1968 by semiconductor pioneers Robert Noyce and Gordon Moore. The American multinational corporation and technology company is headquartered in the Silicon Valley. They are the inventors of the series of microprocessors, the processors found in most personal computers, but also other components like semiconductor chips. Microprocessors are what is described over here, and you can also find the representation of what it looks like on the side. Inside the processor, we can find three units: the control unit that loads the command from the memory to be processed, the registers that stores values for calculation and is connected to the memory, RAM, which is going to do all the calculations, and the ROM, which tells the processor how to operate commands. The advent of low-cost computers and integrated circuits has transformed modern society. General-purpose microprocessors in personal computers are used for computation, text editing, multimedia display, and communication over the internet. Many more microprocessors are part of embedded systems. They allow upgrades in performance with minimal redesign of the product, providing digital control over a myriad of objects that were traditionally not computer-related, like cars, test instruments, toys, and even DVD players. Now, moving to the timeline, we can see the appearance of the Pentium 3 in 1999. The key development to be produced concerned the processor L2 cache. Basically, when data is required from the memory, the execute unit skips it, and the processor looks for the information in the fastest way. First, in the L1 cache on the CPU. If the data isn't there, the processor checks the much larger L2 cache that is connected to the CPU but is found outside of it. After this, all the major processor manufacturers also integrated this processor and is still a trend that continues today. All along, both companies competed and introduced many new processors, but one of the most significant milestones was that both crossed the 1 GHz to Hertz barrier, a speed that many thought could never be accomplished, but only to see that 1 year later, Intel introduced a version running at 2 GHz per Hertz. We could see this trend that was also well predicted by Gordon Moore, and that still is remarkable today. Many developments have followed 18 years from now. Lately, many things have changed. Many new companies are joining the market with new programs, updates, prices, clients, but improvements seem to be limitless. Here you can find some of the developments over the years 2016 and 2017, but many of them are only improvements of previous models. So to see more in depth all the different stages in Intel and AMD components, you can take a look at the link that I left. Today, Intel is still leading the way for instance, with the next generation of desktop processors. But we can also find amazing innovation developments of the future, like plastic processors. Researchers at ARM have been working on a project focused on creating chip disposable microcontrollers printed on plastic. Plastic chips will benefit from an estimated 90% lower IC cost than silicon chips. They can also be flexible, thinner than a human hair, and have no rigid interconnection points. This could lead to interesting use cases, such as sensors around gas and water pipes to record average water pressure or detect leaks. To conclude, we can say that from their humble beginnings 25 years ago, microprocessors have proliferated in an astonishing way. They are powering devices ranging from smartphones to supercomputers. And today, microprocessors for personal computers get widespread attention. In my opinion, these highly complex components are really interesting and really necessary for the new developments in desktop computers. I hope this video was useful and understandable, and thank you very much for watching.